Okay, so there's 4 more trig, and they just are it. We already know the derivative of sine is what? Cosine. We already know the derivative of cosine is?
Sine. 1 minus sine.
Negative sine. Derivative of cosine is negative sine.
That makes a lot more sense now.
Yes, so you need to make sure in your notes you have that right. Okay, and so now we have the derivative of tangent is secant squared, cotangent is negative cosecant squared. Okay, should we know that secant and tangent go together?
Yeah.
Because cosine's in the denominator, right? Should we know that cotangent, cosecant go together? Yes, because sine is in the denominator. What usually throws me off is secant and cosecant. Because secant is secant tangent and cosecant is negative cosecant cotangent. So they all have references, and when you use them a bunch, they start sticking, but they're not going to stick until you use them a bunch. So again, I would start yourself a derivative page. The derivative page will evolve, and every 3-4 rules I give you, I would encourage you to completely rewrite it. Because right now, you're going to have the basic power rule on there. By the end of the semester, you're not even going to think to write that on that sheet of paper because you're going to know it so much. Make sense? So I would put your derivative rules on top, and then your basic ones on top, and then your trig ones down at the bottom, so they're all together. What do I have down here? So I have considering tangent is sine divided by cosine. We can apply the quotient rule. You do not need to write that down. This is just the proof of why it is. Okay? So if I applied the quotient rule to sine over cosine. Okay? So sine would be my numerator, cosine would be my denominator, correct? So the derivative of sine is cosine times the denominator, which would be cosine, minus the numerator times the derivative of the denominator, which would be negative sine, over the denominator squared, which would be cosine squared. So then I would have cosine squared plus sine squared. Well, what is cosine squared plus sine squared? 1. And 1 over cosine squared is secant squared. So that's why the derivative of tangent is secant squared. So better to have the rules than have to do that every time, right? Okay, so let's use them. So it says find the derivative of x minus tangent of x. So this isn't a product or quotient, it's just using a rule. So we're going to take derivative of each of them individually, correct? So the derivative of x is 1, because this is a power of 1. So 1 times 1 is 1, and 1 minus 1 is 0. X is 0 is 1. 1 times 1 is 1. Okay. Minus, and what is the derivative of tangent? Isn't it negative secant squared? Or is it just secant squared? Secant squared, not negative? Yep, see, cotangent's a negative. See, I told you. So I just have 1 minus secant squared of x. So now y equals x secant x. So now I do have a product, don't I? Do you guys remember the product rule before we start? Okay, the product rule is derivative of the first times the second plus the first times the derivative of the second. Okay, what is my... Huh?
Don't we always do that?
Yeah, that was yesterday that I taught you.
But did we not do it there?
On the first one, no. The first one we just did the basic rules.
Okay, yeah.
Okay, so x is my first function and secant is my second, correct? Okay, so y prime. So the derivative of x is 1. So derivative of the first times the second. Plus, well, first would be x. Second, what is the derivative of secant?
Secant tangent.
Secant tangent. And, well, so I can simplify this because this is one term and this is another term. And it's all multiplication, yes? What do those two terms have in common? Secant. So I can factor out a secant, can't I? This one doesn't have an x in the front because it's secant of x. Remember that? That like goes together. It's one thing. Okay, so then I'm left with, well, secant divided by secant is 1. And then plus x tangent of x. And I'll start putting those parentheses around there so it hooks them. And if we were to have like, maybe it said like 1 minus cosine x squared, then that'd be sine squared, right? So if we could apply something, we would. Does that parenthesis does not look like a parenthesis very well, does it? Questions on those two? We just have to remember with the trig functions, we are given specific derivatives. Differentiate both forms.
Wait, would there be a plus in between? Because you just have secant x and then
I have a plus right here. Is that what you're talking about? Or where? First step or second step?
in between secant x.
I have secant x plus x. The x's and pluses kind of blended together, didn't they?
A little bit.
Okay. Okay, so it says differentiate both forms. So we have, it wants me to do this one as a separate problem, and then this one. Well, how did I get from here to here? Well, I got from here to here because 1 over sine is cosecant, correct? And cosine over sine is cotangent. Okay, so it wants me to differentiate both, and I better get the same answer, correct? Okay, so on the left, we need to do the quotient rule. My numerator is this whole thing. Well, the derivative quotient is derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay. So y prime, well, the derivative of 1 minus cosine would be,
It's a good question, Miss Smith.
well, derivative of 1 is 0, correct?
It's a negative sign.
And so minus a negative sign,
Wait, why minus?
because there's a minus right here. Minus the top, which would be 1 minus cosine, times the derivative of the bottom. The bottom is sine, so the derivative is what? Cosine. All over the bottom squared.
Sine squared.
You notice I took the x's out, so I'm not confused with them, right? Will I put them back in at the end? Yes.
How'd you get the sign on the top?
Okay, because we have to differentiate right here. We need the derivative of the numerator. So the derivative of 1 is 0 minus, and the derivative of cosine is negative sine.
So the top is F and the bottom is
G. Yes. Do you want me to use D's and N's for denominator and numerator? Okay.
Wait, what was if you had a number before cosine? Like you had like 7, would it still be 0?
Yes, any constant, because if I have a constant just by itself, that's x to the 0, yes?
Yeah.
So it's going to be 0. It would be 0 times your constant x to the negative 1, well, this is going to make it 0, so it doesn't matter that that's to the negative 1 because you're still getting 0. The derivative of any constant is 0. Okay, so now I need to consolidate, right? So negative negative would be a positive. And then over here, we'd have minus 1 plus cosine squared. Because the distributing the negative. Oh, wait, that's wrong. That's wrong. That's wrong. We need to distribute a negative and a cosine, don't we?
Yeah.
Okay, so that would be negative cosine plus cosine squared. All over sine squared.
Where'd the 1 go?
Well, you're distributing, you basically have negative cosine times 1 minus cosine. Because you have a negative 1
Yeah, okay.
and a cosine. So that would give you negative cosine plus cosine squared.
And it's, for the first one, it's 1 minus cosine times cosine because sine turns into...
Yes, the derivative of sine is cosine.
That's what messes with me when I gotta switch it
Yeah,
out.
Yep.
because it's on the bottom, that's what throws me off, and it's not negative or anything.
Right, no. Because the derivative of sine is cosine. So now do you see why the importance of a derivative sheet?
Yeah.
Get those started, guys. Big study skills. Even you writing them is going to stick them more. Okay. Can I simplify this anyway? We don't even have like a sine squared.
Well, can you
Oh, you know what? We forgot something.
take out a
What did we forget in this section right here?
Oh, the other part, the other.
We did F prime. What did we
forgot the
forget?
G. Just the G.
We forgot just the G, didn't we?
I was wondering why it kind of looked really.
Yeah,
small.
because I'm going, if I had sine squared plus cosine squared, I have what?
1.
1. And so I'm like, I can't do anything with this. And then I'm like, okay, let me go back and look at my work. We did F prime, but we forgot to throw in the what? G.
So sine.
So-
You get sine squared.
So I have to add in sine. So then it would be sine squared. Okay, this right here, the
And
red
it's
box,
1.
or now it's going to turn blue, Ainsley.
Wouldn't it turn into cosine?
Well, it'd be sine times sine, so it'd be sine squared. Okay, but
But the derivative of sine is
we already took the
cosine.
derivative. No, okay. The blue box is F prime, the derivative. The blue box, we already took the derivative. We took it great. We forgot to plug in the G, which is the denominator. We forgot to also multiply times that.
And it's not negative or anything.
No,
because
it's just it. It's not derivative or anything. So what is sine squared plus cosine squared?
1.
1. So we now have 1 minus cosine of x.
You know what I would have done, Miss Rick? I would have just crossed out both the sine squares, though.
Yeah, that's wrong. Remember, if you can't factor, you can't reduce.
But that's
Because
how my
this,
brain
but your brain's wrong. That is a quantity. You need, once you put a plus and a minus in there, Jaden, on that numerator, you need to be put in parentheses. Got me?
works. Keep it together.
Keep it together. Unless you can factor, you cannot reduce. Anytime, numerator or denominator, you guys put a plus or minus, put parentheses to keep it together. You and Riley love to do that. Stop it. I don't know what else to tell you. Stop it. Okay, so that was this, the derivative of that
Can I
part.
try the next one on my own?
Yes, because the next one, you both can. So now you need to take the derivative of this. So you both can. Try it. Those are going to use rules from today, correct?
Yeah.
Can I start?
Yeah.
Ainsley, is it okay if I start? I may be wrong. You guys have to. I don't remember my rules yet. Now, if I simplify it more than you, don't get worried.
The G on the first one. You did the derivative of G. I mean, you forgot that.
But this one isn't a product or a power rule. This is a basic.
See, yeah, you fooled me there too.
Did I fool you?
Well, that's what I was kind of doing. I was like, this doesn't feel right.
Okay, so
I
this.
think I was still trying to do what we just did.
Right. And so is it going to be something for a while that we have to stop and think about which rule we're using?
Yes.
Yes. So this one doesn't involve multiplication or division, does it?
No, so what do you do
No.
on that
So
one?
what is the derivative of cosecant?
Secant and cotangent.
Isn't it negative secant cotangent?
Yes.
Okay. Because I'm learning. If I do it wrong, let me know, because I have to review it. So the derivative of cosecant is negative cosecant cotangent.
Yes.
And then minus, and what's the derivative of cotangent? Negative cosecant squared?
Okay, I remember doing that now.
Okay, so why is the first one the quotient rule and the second one is just basic derivative rules?
Because that second one doesn't have the groupy things.
It doesn't have parentheses, it's not multiplication, it's not division, it's just a basic problem.
That's
So-
why it looks so weird.
So if it's not multiplication, if it's just addition and subtraction,
You just do your
replace it?
basic derivative rules.
You just replace it with what it is.
You do the derivative of the first plus or minus the derivative of the second. If there's no multiplication or division involved or a function, and we're going to use that, we're going to learn that this week later. Okay, so now I have a negative. I switched these two around because I had a negative times a negative, which made it a positive. I just put the negative behind because I didn't want to forget about it. Is that okay to do? Mm-hmm.
Wait, how did you get the 1 minus?
Well, what do they both have in common? A cosecant?
Oh, okay, I didn't even see that you took.
Yep, so I factored out the cosecant. Now, I said these two things were supposed to look alike. Do they? No, they don't look alike.
Well,
But
No.
do I also have one in sines and cosines and the other one in what?
that's what I was about to say. You can flip it around.
I can do some manipulation. So do you want to change the left to the right or the right to the left? Which would you rather plug in a value to? Sines and cosines or cosecants and cotangents? Sines and cosines. So let's work on this and see if we can get it to that. Okay, so we found the derivative, yes? But they should equal the same thing, correct? They should equal, if it says equal at the top, the derivative should equal also.
Wait, I don't-
Okay, so what is cosecant? Let me get a different color. What?
1/sin.
Okay, 1 over sine. Okay, and then 1, right? Minus, and what's cotangent?
Cosine over sine.
Cosine
Look, we did it.
over sine.
How do you get the ones to make one?
Then we get 1 over sine minus cosine over sine squared. Yes? These don't equal, do they?
No.
No. Because this, if I get common denominators, this would be sine. So I'd have sine minus cosine over sine squared, wouldn't I? So something went wrong somewhere because they should be equal, yes? So which one of these was a more complex derivative to find, the left or the right?
Right.
You think this? You think this?
Never mind, because that's the only plus.
That was pretty basic, right?
Yeah.
That was, but we can check this one quick, can't we? So let's check the right, make sure we did it right. Okay? So check on your sheet. Derivative of cosecant, is it negative cosecant cotangent? Check your notes.
Yeah.
Okay? So we did that right. Because part of us doing this is finding our mistakes, right? So then we have minus, because it's minus. And the derivative of cotangent, is it negative cosecant squared?
Yes.
Okay, we're good there. A negative times a negative is a positive. And I moved it over here, and I did that right. I didn't forget it squared or anything like that. I did forget something. When I factored out a cosecant...
It would be adding because the first one's negative and it's minus.
No, that wouldn't be adding, because when I move it, I have to move the whole thing. So this would be positive and this would still be negative. But I did something when I factored out a cosecant. This is cosecant squared, yes?
Yeah.
When I factor out one cosecant, what should I have been left with? I have cosecant squared. I factored out one cosecant.
Wouldn't it be cotangent over cosecant?
Mm-mm.
You've done nothing. It's gone.
Hey, if I have cosecant, because factoring is division, yes?
Yeah.
Divided by cosecant, what do I have left?
Cosecant.
And what did I have left? 1. What should that 1 be? A cosecant. So I messed up the one that was supposed to be easier, didn't I? So I should have cosecant times cosecant minus cotangent. So can we mess up on basic things if we don't be patient?
Yes, Miss.
Yes. So now, if I did that, I would have, am I going too fast?
No.
Now I'd have 1 over sine times 1 over sine minus cosine over sine. Yes? Which would give me 1 over sine squared minus cosine over sine squared, which would give me 1 minus cosine over sine squared. Now, are they the same?
Yay, we did.
Okay, so we took more care on the one that was more difficult than we did on the easier one, because on the easier one we kind of went on autopilot, right?
That's because I understand sine and cosine.
Okay, so did they equal the same thing?
Yeah.
Yes. So can the quotient rule be used instead of having to divide each one? Yes. So what it comes down to is those problems last week that you had to rewrite in order to find the derivative. We don't always have to rewrite them, do we?
No.
We can use our quotient or our product rule and save us some steps. Okay? I think that is the last slide. But Jaden had a question. What if, like...
Oh, yeah, putting it back into it.
Yep. So if I wanted the slope of the tangent line at pi over 2. That's 90 degrees. So I'm going to plug... So I have 1 minus the cosine of pi over 2 over sine squared at pi over 2. Okay, so what is the cosine of pi over 2?
Isn't it 0?
Mm-hmm. So this is 0. What is the sine at pi over 2? 1. So this is 1 squared. So 1 minus 0 is 1. 1 squared is 1, so the answer is 1. So is that where you had a question? You do the whole derivative first.
So like, I have cosine x minus x sine of x. So do I put pi over 6 into all 3 x's?
Yes. So you might end up with a pi over 6 in your answer. Or a pi over something. So you have cosine x minus x sine of x.
Yeah.
Okay. So, and your x was pi over 6. Okay, so you have cosine of pi over 6 minus pi over 6 times the sine pi over 6. Okay, what is the cosine of pi over 6?
That's a very good question, Miss Smith.
Well, pi over 6 is 30. Opposite of 30 is 1, so adjacent's the square root of 3.
I think we need to have a review day over
So square root of 3 over 2 minus pi over 6. And if the cosine square root of 3 over 2, the sine is 1/2.
Wait, how come we did like whole numbers last time? Oh wait, never mind. That's because it's never mind. Yeah.
Okay. So now I have square root of 3 over 2 minus pi over 12.
Can you do, yeah. Can you do
Okay,
that?
so I gotta multiply this by 6. So I'd have 6 square root of 3 minus pi over 12. And that's a nice, lovely answer, but that's the
So
answer.
I pretty much put it in. I figure out what it is on my little graph thing, and then do the problem.
Or you do your 30, 60, 90. So 1 square root of 3 and 2. So opposite is 1, adjacent is square root of 3, so adjacent over 2. Yes?
Yeah, well, I'll review that.
Yes, you need to review that. There's a lot on that slide.
Yeah, give me a minute. I need to write this down.
You get rid of all this extra stuff. I should have just gone to the new slide. I'm sorry. Does this help? Don't know what happened. Okay.
You're good, Miss Smith.
No, I was freaking out because I thought maybe it would go away. There. Is that better? Besides the big
Wait, how
purple
come?
arrow.
Oh wait, are we times 1/2 because it's like the pi 6 with the sign?
Mm-hmm. Because the sine of pi over 6 is 1/2. So pi over 6 times 1/2. And that seems like a weird answer, but you said that's, I mean, you had to find the derivative first, yes?
Yeah,
And that's what you got?
it's because it's correct.
Oh, it's okay, so the derivative is correct? Okay.
I have like 5 of these problems.